Hello class, and welcome to Notes on Domain and Range. As a reminder, I have no voice, so it sounds very different than normal, but it is what it is. So these are your notes, hoarse, voice, and all. We are talking about domain and range this lesson, so we need to know what that is. Long story short, domain is the set of all possible input values of a function. In other words, the domain is going to be all of the possible x values. Sometimes it might be confusing to hear possible x values. What do I mean by that? Well, for example, if I have this function, f of x equals the square root of x, it is not possible for me to plug in a negative number for x. And the reason is I cannot square root a negative number. I'll prove it to you. The square root of -4, it says non-real answer. So it's not possible. So what that means is it's not possible for me to plug in -4, which means it's not part of the domain. The range is all of the possible y values, okay? So this one is the possible output. So with functions, we plug in numbers. Those are inputs. The answer is our output. It's what we get out. So the range is all of the possible answers I can get. So for example, if I have this function, all of the possible y values. If I have this function, f of x equals the square root of, or not the square root, rather the absolute value of x. If I plug in a negative number here, like -4, the absolute value of -4 is +4. If I plug in a positive number, I also get a positive. So all of my output values will always be positive no matter what. I'll never get a negative output, which means my range is going to be restricted. So that's the gist. It might not make a lot of sense, but it will when we put some examples to it. We are going to write our answers out in what's called interval notation, and I'm going to come back to that in just a second. But first I want to do some of these examples. Okay, so if I give you a table of values, the x values are your inputs, the y values are your outputs. So the domain is all of your x values. You're just going to list them. So my domain for this are 0, 1, 2, 3, and 4. And technically you're supposed to put it in this notation. So these are called braces or curly braces. And that's just saying it's a set of numbers. Now for the next part, the range, I'm looking at my output values. So my output values were 1, 3, 5, 7, and 9. And that's all you do for these problems. So for part B, your domain are your x's. 3, 5, 7, and 9. And your range, your y's. -1, 0, 1, and 2. Okay, your TA is going to do part C with you, so you guys can pause the video and do part C together, or try it on your own. For example 2, if I give you ordered pairs, it's the same thing. Remember, all ordered pairs are x, y. X's are your inputs. So your inputs are your domains. So your domain is 9, 8, 7, and 6. Technically, you should write at least to greatest. So this was greatest to least, so another way to write the answer would be 6, 7, 8, and 9. I'm not too picky on the way you do it. Now, the range is your y values. So my y values are these ones. So 5, 4, 3, and 2. Or you could write it the other way, 2, 3, 4, and 5. Excellent. All right, so we're going to get to graphs now. We're going to find the domain and range of these graphs. So these are continuous graphs, and we are going to write our answers in interval notation. So let's backtrack to this really fast. Interval notation is how we write the domain and range of a continuous function. Inclusive values get a bracket, exclusive values get an infinity. So, I'm sorry, such as an infinity get a parentheses. So, let's talk about that. Inclusive is going to be filled in circles. Exclusive will be an open circle or an infinity. Right now, that might not make sense, but let's talk about it. Example, the domain of a function starts at 6, including the number 6, and goes to infinity. This is how we would write this in interval notation. If we're including the number 6, we put a bracket. So it starts at 6, and it goes forever to infinity. So we write a comma and then an infinity. Infinity always gets a parenthesis. So this is my answer in interval notation. The range starts at negative infinity and it goes until 8. Whatever it starts at has to come first. So if it starts at negative infinity, it looks like this. Infinities always get a parenthesis. It ends until 8, and the 8 is inclusive, which means we're including 8 in our answer. If we're including 8, we put a bracket. So you might be thinking, well, what if we don't include 8? If we don't include 8, then instead of a bracket, we would put a parenthesis. And all that means is it gets really close to the number 8, but it doesn't include the number 8. Let's do some examples with graphs. The domain on a graph goes left to right. I want you to write that down. The domain goes left to right. So, and we have to use x values. Let's write that down as well. So on this graph, where is this graph starting from the left? I'm going to use this line to help. Okay, so from the left, the graph starts right here. What's the x value of this starting point? It's -4. So from the left, we start at -4. And then it goes on, it continues on, starts at -4, continues on, and it stops here. What's the x value at this point? We got to use x's. The x value is 2. All right, the other thing we need to look at is that these are both filled in circles, which means they are inclusive. So from the left, we start at -4, and we go until the number 2. And they're both filled in circles, so we put brackets. That is the answer. For range, range goes bottom to top, bottoms up, as I like to say. I'll say bottom to top. And instead of using x's, we're going to use y's. So where does this function start from the bottom? Well, it starts from the bottom, and now it's here. Okay, lame joke, but you guys hopefully get it. So from the bottom, we start here. The question is, what's the y value there? The y value is -7. And then the top is here. And what's that y value? It's 5. These are filled in circles, so we get brackets. So it's -7 until +5 for the range. Let's do that again. Okay, for letter B, domain from the left We start here. What's the x value? It's -3, but be careful. This is an open circle. So that means it's not including the number 3, which means we put a parenthesis, and it's -3, not 3. It stops on the right here, which is the number +2, but this one's a filled in circle, so it gets a bracket. Be really careful, because the bottom of this is not a dot, and it doesn't have to be. The bottom of this is here at -5. Now, if there is no dot, we automatically assume it's a closed circle. So this starts at -5, and it includes -5, and the top is here at 4. The 4 gets a parenthesis because this is an open circle. We may need to pause to explain, but I'm going to move on. Pause if you need to. We're going to go to infinite graphs. Infinite graphs have arrows, not points at the end, or endpoints. So this one, domain, left to right. This may be hard to see, but the question is, how far to the left does this go? And the answer is, it's going to go forever, okay? Why? It's hard to tell, but it might be easier to look here. This point is, or this parabola really, is going to keep getting more and more wide. It's going to keep going to the left. It gets a little bit more wide every point. And it's going to keep doing that forever. It's going to go left forever. And the same thing on the right. It's going to keep moving a little bit more right with every point. Okay? It might be a small amount, but it's still moving to the left, and it's also moving to the right every single point. When this happens, the domain is negative to positive infinity. It's going to go forever to the left, and it's going to go forever to the right. The range, I like to say, is bottoms up or bottom to top. So for the range, the bottom is here, just like we did in the last example. We automatically assume it is a closed circle. It would be an open circle if it was not. This y value is -3. And then it's easier to see this, that these arrows are going up, which means it's going to go up forever. And forever in mathematics means infinity. And since this is going up, it goes to positive infinity. If it was going down, we would be going to negative infinity. Infinities always get parentheses, so that's my answer. There is a trick that I like to use. You know, tricks in math are tough because sometimes there's exceptions. But if there are 2 arrows and the function is continuous, meaning there's no break in it, then the domain will always be negative infinity to positive infinity. If there is a left arrow, then it's going to go to negative infinity for my x values. And if there is a right arrow, then it's going to go to positive infinity. And it's for the same reason as parabolas. This is getting, it's even smaller, but it's going a little bit more to the right with every single point. It's going to slowly continue going. I meant to say left, I'm sorry, off my A game, but it's going to keep going left a little bit more and more forever. So that is our domain, negative to positive infinity. Now the range is a little bit easier to see. This does go down forever. So down forever is negative infinity, and you have to start from the bottom. So if it goes down forever, then the bottom is negative infinity. But it also goes up forever. So that goes to positive infinity. So that's my answer. And then finally, we have this one, the domain. There are 2 arrows, so the trick works. If I have 2 arrows in a continuous function, the domain will be negative infinity to positive infinity. But why? Well, this one's a little bit easier to see. This arrow is going to keep going towards the left. All of these points are getting further and further to the left. And all of these points are going to go further and further to the right. For the range, the bottom, this does go down forever because the arrows are going down. So if it goes down forever, we have to start at the bottom, which is negative infinity, and it goes up till here. So the top is 2. Since we don't physically see an open circle, we assume it's closed, which means we include 2 with a bracket. Those are the notes. Okay, domain and range can be a little bit more abstract than we're used to in math class. So take this moment to pause, ask questions, ask to clarify, and we'll review this tomorrow, but you are to go on to do your homework, which is worksheet B. All right, have a good one.